What's next after Game of Zones?
I'm watching a progress bar, which is slowly starting the live stream. All right, cool. We are now live on YouTube, as far as I can tell. To everyone watching, thanks for joining in. We're going to give, I know you may have seen a tweet which referenced a relayer demo. We want to practice that demo a little bit more, so we are going to give that at a later date. But today we'll give a quick status update on IBC 1.0, some of the work that various entities in the Cosmos ecosystem are doing to prepare for that, to prepare for the Stargate upgrade, in which IBC will be one of the major features. And we're glad to answer any questions, which you should be able to submit on YouTube. I need to figure out how I can see them, but presumably there exists a way to do that. And I will figure it out before you ask them. So ask away. Here today, we have myself. I'm Chris. I work at Interchain GmbH, sort of leading specification and development of IBC. We have Colin. You want to introduce yourself briefly, Colin?
I am Colin Exnier. I also work at Interchain GmbH, and I work on IBC currently.
Colin is currently doing a fantastic job fixing a bunch of tests. He caught several bugs. So if you're using IBC, you will be relieved to know that Colin is on the job finding mistakes. And he's also working on the solo client, which will allow solo machines, not just blockchains, to speak IBC. Michelle, you want to introduce yourself briefly?
I'm Michelle. I've been on some IBC calls before. I work at Tendermint Inc. and I predominantly focus on marketing.
Fantastic. And the reason why people know about IBC and why you are watching this video, because all the engineers would just rather, sit in our secluded dark corners with our backlit keyboards and type. Michelle is prominently often responsible for getting IBC out into the world where it needs to be. So what are we working on? Many of you have probably hopefully participated in a game of Zones, which was run by the Cosmos Devs organization and Inclusion, and IG has been working on all of the technical work behind the scenes, primarily on the Golang Cosmos SDK implementation of the IBC protocol, on the specification to get ready for production ready IBC 1.0. Just as a brief summary, some other entities which are also doing ongoing work on IBC include Inclusion, which / Cosmos Devs, which ran Game of Zones and has been so far doing a bunch of excellent work on Relayer, which many of you used during Game of Zones. Also Informal. Informal Systems is working on formal verification of several parts of the IBC protocol, particularly the tricky handshakes and some of the correctness, soundness, and exactly once delivery, various properties of packets, sends and receives. And they're also starting work on and getting pretty far so far, at least on the Relayer part, on work on an IBC implementation in Relayer in Rust. You can find all of that on their GitHub. But the initial version of IBC, which we're all excitedly awaiting, will be the 1.0 release published at the same time as Stargate. So just as a brief recap, for those of you who maybe have heard this term but don't know exactly what it means, Stargate is a code name which probably has been announced by somebody else other than me. I'm not intending on, it's not my name. I forget, maybe it's Saki, I forget whose idea it was, but Stargate is the code name for the upcoming, it's not really just a Cosmos Hub upgrade, it's more like a Cosmos ecosystem upgrade, because we want to launch new versions of Tendermint in the SDK that have several major backwards, incompatible breaking changes, which bring a lot of performance improvements and feature additions to the Cosmos ecosystem. Predominant among those are two. The switch from a previous encoding library called Amino to a more standardized library called protobuf across our whole stack, which has to be coordinated. So this applies to Tendermint, applies to the SDK, it applies to IBC. It also applies to, not only does it apply to state encoding, so how data is encoded in the blockchain, it also applies to encoding that is relevant for a client. So if you're querying things using HTTP requests or otherwise sort of indexing parts of blockchain data, you will need to update your interfaces to use the new encoding standard. The second major feature, of course, is IBC. We are planning on adding, of course, the 1.0 IBC implementation in a hub governance upgrade subject to approval of the atom token holders. And we are planning on releasing, of course, as always, releasing all of this as open source and encouraging other chains to adopt IBC pretty much at the same time, because IBC is only useful when multiple chains are adopting it at once. It's not so useful if it's just a hub. I think I've talked for at least 5 minutes straight. Michelle and Colin, did you want to add anything? Did I miss anything? Should anything be clarified on that summary?
Could you talk about Game of Zones a little bit, how that went, the results we saw there?
Right. So Game of Zones, which is primarily run not by ID but by Occlusion, but we all, all the entities have been working together on comms and on technical development very amicably. Game of Zones was a competition to do several things at once: to test the IBC software, to train potential operators such as validators who would operate relayers, and zones who would incorporate an IBC, to train them in how to use the software and what it looks like in practice, and to perform certain kinds of load testing on our software that really have to be done in the wild, that are difficult to simulate. We can't, the best way to simulate a real world network environment with potentially adversarial actors is to deploy the software into the real world and incentivize actors to behave adversarially, which we did in Game of Zones with various prizes. So there were 3 phases, which had different awards for different, I think the first phase primarily included keeping a connection open, in the presence of lots of transactions and various sort of countervailing trade-offs between light client unbonding period and ease of keeping the connection open because you don't want the light client to expire. That was phase 1, phase 2, and phase 3 included a much more open-ended prize for exploits, or exploits both in the category of technical mistakes in the protocol, or things which would have led to a result that obviously wasn't intended by the user, but also mistakes in user experience or ways in which using IBC would be unclear or lead someone to do something that they probably didn't intend to. And all 3 phases, I think, were successful. There were a few bugs in the IBC software, which we are very grateful to the community for investigating and catching, and we apologize if they occasionally consume more time than you would have preferred. But it really is invaluable to have the community support in testing the software. We also found some user experience points that need to be clarified, and some lots of minor bugs to be fixed. Nothing nothing I would class in the category of design flaws. Sort of a broad topological architecture of IBC worked as we expected it to, and seems to be comprehensible. No one tells me that it's not, but maybe I just not paying good enough attention. So feel free to ask questions in chat.
So I have a quick question then for you. Now that we finished Game of Zones, and we're working on IBC, and we're working on the Cosmos SDK IBC implementation, what is the best way for people to get started playing around with IBC or the Cosmos SDK with IBC, the relayer, and then the time frame that you consider for when it will actually be part of what people can use?
So the IBC software is usable now. We haven't yet decided to call it 1.0, which is just sort of a decision on what to label a particular version. Okay. We have a few more features that we want to finish before we decide to label it 1.0 and test. Some of those are already basically done. Aditya, who works at Interchain GmbH, just finished work on a generalized Merkle-proof format, which will allow stores other than, or backends other than IAVL to be easily supported in IBC. Colin has been working on the solo client. Fede has been doing fantastic work on the proto migration, and alongside, of course, the rest of the SDK team. But those are all auxiliary features that we just decided to include at 1.0 because we think that they will make future adoption of IBC easier. We don't actually need a generalized proof format now, but it will save us time. in the future. So if you want to use IBC in your zone, the software is already at a point where you can import it, where you can figure out how the interfaces work. The documentation is a work in progress, but it's there, and the code itself is very well commented, and the ICS 20 module in the SDK, which handles token transfers, is a very clear example of how you actually interface with IBC. So if you plan to use IBC as an application developer, I recommend taking a look at the ICS 20 module and sort of starting from there. If you plan to use IBC as a operator, as a validator or a relayer, you are probably best suited by going to the relayer repository, which is github.com/inclusion/relayer, where you can find instructions for running a local testnet, for relaying between two chains, for connecting two chains to each other, and performing all the relayer commands that interface with various parts of the IBC process. Relatively soon, and I can't name specific dates, but relatively soon we plan to have a Stargate testnet, which will be perhaps we need to call it something else, actually, because the primary goal of this testnet will be to test multiple blockchains at once. So it's not just a test for the Cosmos Hub, it's a test for the whole Cosmos ecosystem upgrade process. That will mean that we want that testnet to include IBC, and we want to include specifically other zones which plan to launch IBC around the same time the hub does, and who would like to be included in that testing process. So we'll announce more details about that soon.
So, but just quickly, for a testnet like that, what does that mean for people? Would that be anyone can get involved in the testnet? Is it heavy lifting for people, or is it similar to the testnets we've run in the past? How can people prepare?
Right. Some details are still to be tied down. Certainly, it will be possible to participate, as a casual observer or someone who wants to play with IBC in this testnet, and that's a great thing to do too. Primarily, our goal is to get as close to we can to an exact simulation of the actual deployment process of Stargate, so that we can iron out any kinks ahead of time rather than in production when live funds are not yet at risk. And to that end, we especially will be encouraging people who plan to operate relayers, people who plan to launch IBC on their zones and connect to the Cosmos Hub to participate in that testnet. But that doesn't, that's relevant to testing the deployment process. If you want to use IBC in your zone, most of the work that you'll be doing involves application development, involves thinking about relayer incentives, involves writing the modules in probably in using Cosmos SDK that are going to talk to IBC, that are going to send and receive, parse, and encode IBC packets, and all of that work you can already start doing.
Is there any, I don't know if you would know the answer to this, or just it might be helpful if people are planning, will there be plans to audit IBC, or will that be kind of up to individual projects to manage on their own?
That's an excellent question. There are different layers of IBC. What we've often called the core layer, or the Tau of IBC, which handles transportation, authentication, and ordering. That's the part which we've mostly been developing. And that is, it sits below in the protocol stack, the application layer. So ICS 20, which handles token transfers, is an example application layer module. And the core protocol has gone through some audits. I'm not sure if the report's been publicly released, but I'm sure that we can do that. In a few months ago, which was not the exact version of the software we have now, but it was relatively close. We plan on, I'm not sure if we will do more formal audits of the protocol prior to Stargate, but we certainly will launch a public bug bounty. And historically, public bug bounties have been the most effective way of catching particularly nasty bugs, say in the proof of stake system or in Tendermint. So we plan to do that for IBC as well. Now, that does not cover the application layer, other than perhaps ICS 20, because most of the application layer modules will be written by zones, by users of IBC. If you want an analogy that may help, is to think about the internet protocol and websites. So the TCP/IP TLS SSL stack by this point is quite well audited. For a while, there have been bugs in TLS, which were pretty catastrophic, but hopefully there's enough attention being paid to it now. However, it is quite possible to use TLS, which itself presumably is secure, and to make mistakes in your website or in how you're storing passwords in your database or something. So you need to audit that layer as well. And that is dependent on what people are using IBC to do. Now, we also want to encourage at that layer standardization, so that in part, so that, or probably predominantly, so that multiple chains can interoperate. They need to agree on a packet standard, agree on how packets are encoded and transmitted. They don't need to all agree at the same time. So you can have two chains which just know how to talk to each other using a particular kind of packet, and that's fine. And as soon as someone else wants to talk, they can implement code to speak the packet format as well. But presumably there will be a lot of applications, different kinds of token transfer, voting, cross-chain, say transferring code of a particular instruction format that benefit from standardization, both so that it's easy to adopt best practices across many chains, and so that costs such as for auditing and for compliance and design can be socialized across a great many implemented chains. So our that can happen regardless of whether we authorize it or not. We play no formal role. No one needs to rubber stamp IBC protocols. You can just build one and start using it. But we do plan to coordinate a standards process, which you can find described in the ICS repository, and submissions for application protocol standards are always welcome.
Chris, when IBC 1.0 happens, I know there will be a time period where like the next features for like IBC 2.0 will, like what happens then will kind of dictate which features are going to be implemented. Is there any features that you have like you're going to like watch closely to see if there's enough demand for that?
Great question. At the risk of veering off too far into fantasy protocol land, I think there are a lot of more interesting or more precise methods of providing ordering guarantees across many blockchains. So version 1.0 of IBC supports two kinds of channels, ordered channels and unordered channels. In ordered channels, packets are received in the same order as they are sent. This is helpful if you need to reason about state changes which have cross dependencies between packets. In unordered channels, packets can be received in any order. That is most suitable, or an unordered channel is most suitable, where packets execute state changes that are independent, like token transfers falls into this category. You don't need to wait for someone else's tokens over a channel to be dispersed as vouchers on the destination chain before you can disperse yours. And unordered channel, if you don't need an ordered channel, you don't want to use one, because unordered channels can be more flexible with timeouts and can allow for gas markets to sort of operate in the underlying way without interference. However, there exists sort of a spectrum of ordering possibilities in between those two, where you may not need full ordering, but you need causal dependencies between some packets. And it is possible, certainly in principle, to implement this feature in IBC. And there's been a little bit of brainstorming. There's an issue on the ICS repo, I think it's called directed acyclic graph packet ordering. But the basic idea is that IBC channels would allow you to specify the causal relationship between the packets that you want. So if you want it to be on the sending side. So on the sending side, if you want, let's say you have packets 1, 2, 3, 4, and you want 1 to be received before 3 and 2 to be received before 4, but between the two, you don't actually care. It would be fine for it to be 2, 4, 1, 3, or 2, 1, 3, 4. There's another possibility as well. And that, so then you can, then if they're, depending on what the gas market does, you have some more flexibility. And this is, we would probably do this by having basically chains of hash references in packets, so that a packet would contain like a hash of the packet or packets which needed to be received before it was, and we would use some sort of accumulator to track this. Now, that may be a super useful feature for advanced applications, or it may be a interesting protocol design that no one ever actually wants to use. So we are purposely being a bit conservative. You know, IBC 1.0 has plenty of exciting features, but we will wait on certainly on doing anything too fancy to see how the protocol is used in practice. And even more importantly, I would say, than judging whether or not the features that we thought of are good ideas, we'll be trying to gauge what features we didn't think of might be necessary for use of IBC in practice. Now, we have built conscientiously into the protocol a ability to upgrade parts of it. Most of the logic in IBC happens at the channel layer, where packets are sent and received. All of the ordering logic is dealt with there. All of the acknowledgement logic is dealt with there. And we have considered, maybe not perfectly, but hopefully to some degree, the process required to upgrade many blockchains running IBC. Now, the critical consideration, we think, is to allow for the coexistence of multiple versions of the IBC protocol itself in a connected topology of many blockchains. It's going to be impossible to coordinate, right? So if there are 100 blockchains in speaking IBC, which is hopefully there'll be many more than that, but a conservative estimate, 100 blockchains speaking IBC, say next year, getting all of those blockchains to use their upgrade systems to simultaneously switch to a new version of IBC, which is backwards incompatible, is just impossible. It's a non-starter, not going to happen. Governance of one blockchain is already usually a extremely difficult and problematic process. Somehow getting all these governance systems to agree, it seems like a fool's errand. So instead, we are trying to build IBC such that chains can implement a new version of IBC, which maintains backwards compatibility with at least the most common old versions. But when a chain which has the newer version talks to a chain which also knows how to speak the newer version, they can negotiate that in the connection handshake, which I think you've also been working on, Colin, and they can agree to agree that they both support the newer feature set, and then the newer feature set can be used. So some of the features, which in fact a lot of the features, including direct-to-day cyclic graph packet ordering, can be implemented in this way. It would be possible for chains which speak IBC 1.0 to continue to exist, while some chains could upgrade. We would probably call this 1.1 instead of 2.0. Some chains could upgrade. They would support the new sort of direct-to-day cyclic graph channel, and chains which also supported that could set up those kinds of channels, but chains which didn't would only support the older kinds of channels. Let's see, any questions so far on the YouTube chat? Not yet. Feel free to ask anything about IBC.
I mean, I'm just looking quickly at some of the notes from more of like the core teams meeting. And there does look like a discussion around Rust IBC. Is that something that Rust IBC implementation, is that something that will be coming along?
Yes, Informal is working on an implementation of IBC in Rust, both the relayer and the core protocol as modules. I think it's github.com/informalsystem/IBC-RS. They are also working on an effort to formally verify a lot of the IBC protocol, particularly handshakes and the packet send and receive logic in TL8+, which is a file checker. You can also find that on their GitHub.
And maybe I have one more question that I had been following a little bit briefly from the IBC discussions, and I was just curious how kind of an update, or if it was still relevant, is the ICS 23 discussion that had been kind of 2 weeks ago. The IBC core team had been talking about it. Maybe what that is, and if it's still important or relevant to people interested in IBC.
Yeah, absolutely. So I don't know if we should, the nomenclature is still to be finalized. Yes. ICS 23 originally was the name of the general standard and has morphed into the name of a specific, albeit somewhat general instantiation, which is confusing, but.
We need a diagram.
Right. What we have been working on started, and most of the work was done, design work was done by Ethan Fry, and then IG has done, particularly Aditya has done the integration work into the Cosmos SDK, is a generic, or at least a more generic implementation of Merkle proofs. So IBC uses Merkle proofs to provide a vector commitment abstraction for all of its verification tasks. So key to the IBC protocol, the constituent building block upon which it is constructed, is the ability to verify parts of the state of another chain. So when you're checking to see if another chain sent a packet, checking to see if another chain has not yet received a packet, checking to see what the state of a handshake is, all of this requires cross-chain state verification. It requires that on one chain, you have the ability to verify part of the state on the other chain, or in some cases to verify at the absence of part of the state, to verify that something is not written to a particular key. And most commonly in blockchains often require this. It's used in IBC, but it's also used for state verification in traditional light clients running on edge devices like phones. And it can be useful in just providing data integrity and committing to things in blocks with hashes, et cetera. So we want to support a wide variety of methods of instantiating this vector commitment abstraction in IBC. IBC just requires that you have some way to verify cross-chain state. It doesn't really care what it is as long as it fulfills certain properties. And we'd really rather allow the chains themselves to vary as much as possible how they actually instantiate this. Bitcoin uses a very different mechanism from Ethereum, which in turn uses a different mechanism from the Cosmos Hub with the Cosmos SDK. So to facilitate that, we've built a way to sort of specify the kind of Merkle proof that you are going to use when you create a light client. So when you create a Tendermint light client, in the future IBC will also support other consensus algorithms, and it already supports solo clients. When you create a light client, in addition to specifying the parameters of light client validation, who the initial validator set is, you will also specify the basically a brief spec for the kinds of Merkle proofs you're going to be producing and how the light client ought to verify them. So this happens at runtime, which means that when, say, the hub integrates and deploys IBC 1.0, new blockchains which use a somewhat different Merkle proof format will be able to connect to the hub without any more software upgrades on the hub, just by specifying the way that the Merkle proofs need to be verified.
Okay.
So a good thing for zones to do is to check. I mean, if they're using the Cosmos SDK, all of this is sort of built in, batteries included. But if they're using a different database, a good thing is to check to see if it will be compatible with ICS 23 and to file an issue if it's not.
It looks like someone did ask a question on the YouTube channel. So basically they're asking if you could elaborate on the Pegzones being built on the Cosmos Hub and what exactly, I assume they mean what exactly the Pegzones will bring, or maybe they mean what IBC will bring.
Sure. So I would separate the questions of what Pegzones are being built and what happens to the hub. Software development, is a prerequisite condition, but not a sufficient condition for things happening to the hub. What happens to the hub is decided by hub governance, not by us. So I mean, hub governance could decide that they don't like IBC. Like they could decide that they want to do a different IBC, and we would be a little sad, but it's not up to us. It's up to them. IBC would still exist. Other people could use it, but we don't expect that. Hopefully, the hub will like it. But it's up to what the hub does is up to the hub. Now, there are several Pegzone projects being variously funded by the ICF and other entities. There is ongoing work on Peggy originally by Swish Labs and now more recently by Althea, which is a bridge between Cosmos and Ethereum, between a Cosmos SDK chain and Ethereum is sort of a better way to put it. We are purposely architecting the bridges in such a way that they are not, they're not specific to a particular chain. So you could have multiple instances of a bridge quite easily. Now, in practice, it's likely that there will be, due to security concerns, the need to collateralize bridges, to over-collateralize them. It's likely that there will be a few commonly used bridges. And hopefully, in my view, that is something the hub should try to integrate. I think it would be a value add the hub could provide to the ecosystem at large. There's also ongoing work on a Bitcoin peg, although that one I'm less familiar with, so can't comment in too much detail, but I believe it's on Nomic's GitHub. And also great work by TBTC, which could potentially be integrated into the Cosmos software stack without too much trouble. and some other ongoing early stage projects.
I think one cool thing about IBC here is that like you've had these Pegzones kind of thought about and worked on for a while, but now with IBC actually coming into play, they can actually connect up to the hub.
Absolutely. And one advantage of the topology of IBC is that all you need is one connection path. Modulo concerns about security, and you need to be careful when you're sending tokens to blockchains because you're exposed yourself to the risk of their faults. But if my blockchain connects to Colin's blockchain, and Colin's blockchain connects to the hub, and the hub connects to Ethereum, now people can send tokens all the way from Ethereum through Colin's chain, through the hub, through Colin's chain onto my chain, or vice versa. Now, it's a little bit more expensive to do that. You need more transactions. But say if you're just depositing assets or doing some sort of less frequent transfer, as even if you as a chain, only connect to a few other chains, the users of your chain will basically have the closure of the connected graph from your chain available to them as a destination source of assets or of whatever of state operations or for whatever IBC application protocols you support.
So that's a question. Does IBC actually make assumptions about security, or that is dependent on the team implementing? So
right. IBC is in the middle. So it's security assumptions always rely, ultimately there's like physics, but we're not going to go that deep. Security assumptions rely on lower level properties and provide higher level properties. And IBC is situated between low level security properties of, say, a consensus algorithm and high level security properties of an application, like the tokens are conserved, or that if you receive funds, you can spend them, something like that. As does any such protocol, which is situated in between, IBC provides security properties which are dependent or stated in terms of the lower level security properties. So concretely, I realize it's a little abstract. Concretely, that means that if you are doing things with you're transferring tokens between two chains over IBC, that's secure as long as the Byzantine fault tolerant consensus algorithms of the two chains are both secure and their state machines are correct. So a rule of thumb is essentially that when you use a chain through IBC, you are exposed to the risk of that chain failing. Now, IBC tries to build in some mechanisms for at least detecting faults, but they can only detect some classes of faults, and some classes of faults can't be at least automatically remediated at all. This isn't different. When you use Ethereum, you're already exposed to this risk. So IBC just doesn't really change it. It just makes the problem more complex because now there are all these blockchains that you kind of have to choose from at once, which is more complexity to deal with, but it also means that you have more options. And it enables, or could enable, interesting trajectories of security evolution over time. So for example, there is not a strong reason to expect that assets and chains will continue to remain as correlated as they currently are. So, the Bitcoin asset has a lot of mimetic mind share. It has, scarcity. It has a well-known brand. It has lots of interest, lots of connections. The Bitcoin blockchain, on the other hand, all credit to Satoshi, but the Bitcoin blockchain is 10 years old, and it shows. And there's not, were it to be redesigned, it could be probably designed in a at least much more quiescent way that didn't require the energy consumption of the Kingdom of Denmark, but also a way which provided users useful properties like instant finality and better privacy instead of traceable pseudo-anonymous transactions. So I think it's quite likely that assets will move from one chain to another chain, and maybe what's considered the source chain of an asset will eventually change. So right now, no one would really question that the source chain of the Bitcoin asset is Bitcoin, even if there are some synthetics on Ethereum or something. What is real Bitcoin? Real Bitcoin is a private key which controls some unspent transaction outputs on the Bitcoin blockchain. That social consensus is clear. Most of the Bitcoin is still stored on the Bitcoin blockchain. But that could change. If most of the Bitcoin is transferred off the Bitcoin blockchain, and say like 95% of Bitcoin is in fact held as vouchers on the Cosmos Hub or something, then the Bitcoin blockchain may become, I guess it will still have inflation or something, but it may become a lot less useful, or at least it would be unclear if there ends up being some sort of consensus divergence. If the peg breaks, it would be unclear which ends up emerging as the canonical chain. If most people hold their Bitcoin on the Cosmos Hub, then maybe maybe the canonical chain switches, right? So, some interesting possibilities there.
We have a few questions now coming in. Well, we have one about what comes next for IBC after Game of Zones. I think we kind of, I don't know if there's anything you want to add that we didn't cover before.
What comes next for IBC after Game of Zones? Primarily deployment with the Stargate upgrade. So for that, we're working on a few important but not groundbreaking technical feature additions, just sort of between the version of IBC that we use in Game of Zones and the version we plan to deploy in 1.0. And then we're working on a lot of testing, a lot of ecosystem preparation, a lot of coordination between various entities, both technical and communication-wise, to prepare for the launch of Stargate.
Another quick question is, does IBC integrate with legacy systems? They give an example of a centralized MongoDB.
Mm-hmm, mm-hmm.
And they say actually now, but also is that something for the future, if not now?
The intent of IBC is to be as, agnostic as possible about what a chain is. So I've sort of colloquially used chain when I'm talking about the actors which are speaking IBC, but it doesn't actually have to be a chain. It just has to be something whose state can be verified. So could you have a solo machine, as Colin's been working on, where basically a single computer can speak IBC. You could have it doesn't need to be proof of stake. You could have a proof of authority chain or a private chain, or a chain with a completely different consensus algorithm. And you could have, a database like MongoDB does not generally have proof capabilities. So what you specifically need with IBC is the ability to prove things about state. Sort of databases like the SQL NoSQL distinction is not relevant, but databases which are built to run in some sort of closed on premises network generally do not store data in an authenticated manner, because they don't need to prove things because they're dealing with trusted computers. So you could do something like run a database where you had like an auxiliary index that allowed you to generate proofs, or where you just had a key that signed things and decided that you would trust things that the key signed. And that would work with IBC. Now, it working with IBC is a separate question from people wanting to use it with IBC. I mean, the security properties, IBC doesn't magically provide like decentralized blockchain security or something. So if you use IBC and you send tokens to MongoDB, and MongoDB has some, consistency mistake, as has happened several times, or the person who is signing things and authenticating data screws up and signs the wrong thing or is malicious, then your tokens are gone. IBC can't save you. So the buyer, caveat emptor, as it were.
Okay. Actually, that's kind of, you're talking about security, but someone's asking if you could explain about shared security. And will it be needed according to your view, since there's not much information out there with regards to the concept?
So shared security, like many such terms, is a term with a unclear referent, and different people have different ideas of what it means. And I don't mean to necessarily claim the term. I have a particular idea of a particular thing, and it's relevant to shared security, but different people can have different ideas of different things, and if they want to call them shared security, that's fine by me. What I think would be useful is a way for chain speaking IBC to exchange validators in a more flexible manner. So one way of articulating it is this. The basic Cosmos IBC model has completely sovereign chains, which is where chains have disjoint validator sets. Or at least if they happen to share validators, that is coincidental and not in any way known or made use of by the protocol. So right now, this is the case. So the Cosmos sub has some validators, the Iris sub has some validators, Kava has validators, Akash has validators, eMoney has validators. They're all sovereign, which means that they're separate and they don't know anything about each other. And that's great. I mean, a lot of the network is going to look like that. And that is purposefully sort of the initial configuration we went with. Another point in the design space is where you have multiple concurrent, which looks more like sharding, is where you have multiple concurrent execution environments or state machines, but you have a global view of what the topology of the validator set is. So ETH 2.0 or Polkadot or Near all look like this, where generally there's like a coordinating chain that knows what the validator set is and decides how to change it, and a bunch of follower chains, which have subsets of that validator set. Generally, they also know what it is, or know what their subset is at least, and they can make use of that knowledge to provide some additional security guarantees and streamline communications with each other. They don't need to verify so much necessarily. Now, of course, that comes with the large disadvantage of requiring this like one large validator set that you have to coordinate on. And then you sort of need to pick one token and this sort of thing. Which is why we've gone for a different initial approach. But I think there are valuable points in between. Probably the end result is not going to look like either extreme. It will be something in the middle, where, for example, you can decide that you want to rent a few of the Cosmos subs validators to validate your zone, provide some additional security. And the role of a shared security protocol in that application would be to allow for the negotiation of who are these validators, how much are you paying them, how does slashing work, where are they locating their collateral, all of that to be negotiated over IBC. That is one dimension of shared security. Another dimension of shared security, or something that could be called shared security, is, or that I've started to think about, is consensus on light clients. So the basic IBC model is the chains run light clients of other chains, but there are more complex versions of that. One simple, more complex version of that is for a chain to run a proxy light client, where instead of directly validating that another chain has signed some piece of data, or that you can validate a proof of the other piece of data, you validate that another chain has validated that the first chain has stored or not stored some piece of data, or at least that its light client has cut into some particular header. And this is useful because it allows you to save on compute, because then you only, like, for example, if the hub runs a bunch of light clients, and you probably don't want, if there are 200 zones, if all the zones run a light client for each other, there are 200 squared light clients, which is a lot. You can instead only run 200 light clients on the hub, and then all the zones run a light client for the hub, and they can use their light client for the hub to verify the hub's verification of the light client for another zone. So if you only have infrequent packets to another chain-speaking IBC, you may want to use such a proxy client. But there are more, that doesn't have that much to do with security. You're just introducing an additional chain into your security assumptions. You depend not only on the other chain being correct, but also the hub's verification of the other chain being correct. Now, for lots of use cases, that may be fine. So I think it would be a given. But there's another direction as well, which is to have some kind of consensus about what your light clients are actually agreeing on. So one way of thinking about this is, from IBC's perspective, a chain is defined by its light clients. IBC doesn't know anything about what else is going on. It only knows about what the light client can verify. Light clients, depending on the consensus algorithm, depending on what the validators do, can diverge from what the full nodes do. And it may be advantageous to provide some additional assurance by having some, chains which are all running light clients come to consensus about what their light clients say before, say, processing really high value transactions, because their light clients can get different data. Now, in principle, if data exists on one chain, hopefully it will eventually be available on another chain. But if you want to provide some additional assurance against, your chain being eclipsed, say, from information about equivocation or misbehavior, then it might be nice to wait for other light clients to also agree. But another thing you can do with this is build, take this sort of consensus of light clients and build on top of it additional functionality. Because once the consensus of light clients is something that is used in protocols, then itself it starts to carry this weight. So for example, if there's a fork, right? If there's a fork and you're trying to determine how to upgrade your light client, say to follow one fork or the other, maybe in fact you have a bunch of chains vote on which one they want to follow. Because in a sort of large topology, it's advantageous, or will likely be advantageous, to coordinate on these things, because otherwise you can screw up token balances or such things. And one reasonable way, potentially reasonable way of automatic coordination is to have lots of chains which are running light clients kind of vote on how to proceed. So I think that's another interesting design direction. But other people have different ideas of shared security. It can also involve tokenization of particular delegation rights, particular validating rights. It can involve reward payments across chains, which I think is important as well. There are lots of different aspects. Any other questions? We're approaching the end of our hour here.
Yeah, I think that's all we've got.
Alrighty. Anything else, Colin or Michelle?
Maybe when can we? When will the relayer demo?
I will determine that. Not yet, totally sure. But this will be the first of a series of hopefully recurring IBC live streams covering various topics. Hopefully more predictably than this one, but hope you enjoyed it.
Jump on.
Yeah. I mean, eventually we will get to the point where we're scheduling topics in advance and committing to them. But that point is not yet.
And maybe we also, if people want, if there are specific topics or presentations people are interested in having from the team, from Agoric, from Inclusion, from Informal, from Interchange GmbH, if they want to maybe put them in the channel, and we can start building a calendar of presentations.
Yeah, absolutely. Glad to take requests.
Guess that's a wrap.
All right. Thanks, Colin. Thanks, Michelle. Thanks, everyone, for watching.
Thanks.
Ciao. See you next
Thank you.
time.
Bye.